Hi, hello everybody. So this is section 15, rational equations, where we're going to go over the steps to solving these rational equations. So first of all, a rational equation is an equation with at least one rational expression. And what I normally infer by that is where you have a variable x, for example, in your denominator or as your denominator. So in those cases, we need to take several steps to solve the equation, and we have to check at the end to ensure that the answer is valid, because it may not be. So the steps in solving rational equations are: number one, factor all denominators. Okay, that may be necessary. Sometimes it's not, but sometimes it is. Number two, determine the LCD of the denominators. Okay. We've covered this before, right? You should be able to find the LCD uh, of each factor. And then step three, multiply each term of the rational equation by the LCD. Now, this is a very important step because when we do that, the denominators will disappear. You see what I mean? And then step four, we're going to solve whatever remaining equation we have after the denominators have been eliminated. So in step four, we're going to get an answer, x equals something, right? Maybe one number, maybe two numbers. After we get the answer, we have to do step five, which is check to see if the solution is valid. Okay. Now, this doesn't have to be, it's not necessarily that it is a full check, but it's what we call a domain check. Okay. And I'm going to show you as this example before I solve 15.4. We're going to do what your question here on 15.4 says, find the domain restrictions. Now, what does that mean? It means that we have to find the values that would cause the equation to be undefined. Now, whenever you have a rational equation, because you have a ratio, the denominator can never be zero. So this is what we call the restricted value of the domain. So if the denominator is zero, we cannot solve it. So there is a restricted value coming from here, and there's a restricted value coming from there. How do I find it? All you have to do is equate the denominator with zero, okay, in both cases. We don't need to do this because we're going to check at the end, but I'm just showing you now what a domain restriction is. So if I add 3 here to both sides, I get x equals 3. And if I subtract here 3 from both sides, I get x equals -3. Now, these values are the restricted values. In other words, the x variable cannot be 3 or -3 because if it is, we are going to have division by 0. So take a look. If I replace x with 3 here, I'm going to get 3 minus 3, which is 0, which is not allowed. If I replace this x with -3, I'm also going to get 0 here. So these values have to be removed from the domain. So this is what we mean by domain restrictions. Now, we don't need to do this because our check at the end is going to take care of that. And I'm going to show you how. Okay, so let's do 15.4. Now, just keep in mind that we have to do all of these 5 steps I mentioned here above, right? Factor the denominators if necessary, determine the LCD, multiply every term by the LCD, solve the remaining equation, and check the final answer. Now, 15.4, there's nothing to factor. So step 1 is out. The LCD for 15.4 is this times this, right? Just like if I had, for example, 3 and 5, right? 3 and 5, the LCD would be 15. You just multiply the two. So look the way we do this. We multiply both sides by the denominator, okay? And on the other side. Now, We are not actually multiplying, right? We are going to simplify. This factor is going to cancel with this. This factor is going to cancel with that. I'm going to write in my next line what I have left. I have 4 times x plus 3. I'm going to write it this way for now. Okay? Equals. And I have 6 times x minus 3. Notice that after I multiply and simplify with the LCD, there is no more denominator. At this point, I am at step 4. I am going to solve this remaining equation, which is a linear equation, which is very simple. So distribute the 4, distribute the 6. So 4x plus 12, 6x minus 18. It's a linear equation, minus 6x on both sides, minus 12 on both sides, right? Because we need to isolate the variable. This is out. This is negative 2x, and this is out, and this is negative 30. Divide everything by negative 2, and we get x equals 15. Negative divided by negative, positive 30 divided by 2, 15. This is it. Now, this is step 4. I've solved the equation. Notice we don't really solve the original equation. This is the original equation. We solve this equation right here, which is the exact same equation, but written in a much friendlier way. Now, all we have to do, we don't need to find the domain restriction. We have to check. We have to check if this value is okay. So how do we do that? We're going to grab it, the 15, and we're going to replace it only in the denominator. Okay? If we get a 0 as your denominator, this value is not allowed. So let's see here. 15 minus 3, 12. No, that's okay. And 15 plus 3, 18. That's also okay. So the domain check passes, which means that this value is okay. All right? If the 15 produced a 0 as your denominator, you would have to write no solution, okay? Because that's the only possible value we have. But that's not the case. So this is how we solve these rational equations, all right? Let's do the second case, 15.6. Now, again, nothing to factor, but the LCD, again, is the product of the two. So I need to multiply this term and that term by the LCD, which is x plus 1, x minus 2. So every single term. I'm going to write it over here. It's going to be a little bit long, but let's write it. Okay. Now notice that our interest is in canceling things. So this first term is going to cancel that. This is going to cancel this. So I'm going to be left with this product. I'm going to write it as my second line. This product and this whole thing. But notice at this point, I no longer have a denominator. That's what we want. All right. Now I have to distribute the 3x and I have to distribute the 4. So 3x squared minus 6x plus 4x plus 4 equals. I have to do this, and I'm going to do this on the side. I'm going to erase this thing, and I'm going to do it over here because I'm going to need the space. So first I'm going to do x plus 1, x minus 2. I have to FOIL this, right? So x times x times negative 2. So x squared minus 2x. And this is minus x, and this is minus 2. Okay? Plus x, right? So let's check. So x squared minus 2x plus x minus 2. And then we combine these two. So x squared minus x minus 2. So that has to be multiplied times the 3. So 3x squared minus 3x plus minus 6. Okay, that goes right here. And we can always check to see if you made a mistake. Let's do it again. So x squared minus 2x plus x minus 2. This is minus x, and we're going to multiply by 3. 3x squared minus 3x minus 6. Perfect. And now, at this point, I can see I have a quadratic. So all of the variables have to be on the left side and 0 on the right. So I'm going to subtract 3x squared. Subtract 3x squared. I have to add 3x to add 3x. And I have to add 6. Add 6. And see what we have left. These two cancel. I have negative 6x plus 3x is negative 3x. Negative 3x plus 4x is x. And 6 plus 4 is 10. And this cancel, that cancel, that cancel. So I have x plus 10 equals 0. Then obviously subtract 10 from both sides. And I get x equals negative 10. That's my answer. But I have to check. So we go back into the original, and all I have to do is a domain check. So that x is going to go right here and right there, only in the denominator. And you're going to compare that against a 0 if the denominator is 0. So negative 10 plus 1 is negative 9. That's okay, not 0. Negative 10 minus 2 is negative 12. Okay, is not 0. So that means that this answer is valid. All right, that's all you have to do, a domain check. I don't need to check the domain restriction. Let's see another example. This one. This is going to be our last example. It's not any harder, but in this case, look at the equation, and step 1 says I have to factor. So this needs to be factored. Nothing to factor here, nothing to factor there. But the middle term is difference of squares. So x squared minus 9 factors as x plus 3. So I have to factor that. So step 1, I rewrite the middle term in factor form. So for the problems that we're going to give you, you only need to factor the denominator, okay? That's not to say that sometimes a more complicated problem wouldn't appear in a textbook that you have to factor the numerator as well, but you don't need to. Now at this point, everything's factored. You have to find the LCD. Well, the LCD is this, right? Because here's my x minus 3, and x plus 3. So the LCD is, and again, I am not reviewing the concept of an LCD right here, not to make the video longer, but we've covered this in a previous video, so go back and check if necessary. Once we found the LCD, you must multiply every term, the first one, the second one, and the third one by the LCD. So I'm going to write it here. Again, it's going to be a little bit long, but this is for you to see how this is done. Once we do that, our goal is to eliminate the denominator, right? So I've multiplied every single term by the LCD. Now we go canceling identical factors. These two cancel. This cancels with that. This cancels with that. The plus 3 cancels with the plus 3. And then on the next line, I write what I have left over. So 2x, x plus 3, right? 28, just 28. There's nothing here. And the last thing is the negative 6 x minus 3. Notice, at this point, no denominator. We're going to solve the remaining equation. But first, we have to get rid of the parentheses. So I'm going to distribute here and here, and here and there. So 2x squared, 6x, 28, negative 6x, 18. I recognize this is a quadratic. So to solve a quadratic, I have to have 0 on the right. So I'm going to add 6x here, and obviously here. And I have to subtract 18 here, and obviously there. So whatever you do to one side, you do to the other. Okay? I'm going to erase a little bit from here because I'm going to need that space. And I'm going to be left with 2x squared. Here's my 12x. And here is my 10. And these two cancel. So this is the equation I have so far, right? We have to solve it. This is a quadratic, it's a polynomial, and I am going to factor it. Now, before you factor it, you recognize it as a trinomial, which it is, but there's a GCF first. So you factor the GCF, which is 2, before, to make your job easier. Now, this is the trinomial you're going to factor. And you're going to do the AC method as before, right? A times C, which is 1 times 5. And the sum has to be B, which is 6. Well, the only possibility for that is product 5, sum 6, 1 and 5. Right? Product is 5, sum is 6. So I'm going to rewrite the middle term as 5x plus 1x plus 5. And you can flip the order if you wanted to. And I'm going to factor by grouping now. Already covered grouping before. They have nothing in common other than a 1. So 1. X plus 5 is a common factor. Okay. Second parentheses, those two. By the zero product rule now, I either have x plus 5 is 0 or x plus 1 is 0. Minus 5 on both sides gives me x equals negative 5. And minus 1 on both sides gives me x equals negative 1. So I got two possible answers. Here they are. And I solved the equation, but I have to go back and check. And you go back into the original. I'm going to erase this just a little bit so you can see. Yes, these problems are a little bit long, but we have to do a domain check. So you're going to get the negative 5 first, and you're going to go here, here, and here, and see if you have a denominator of 0. So negative 5 minus 3, negative 8, okay. Negative 5 squared, 25 minus 9, definitely not 0, okay. Negative 5 plus 3, negative 2, not 0, okay. So negative 5 is a solution. So you can write negative 5, okay. I'm going to do the exact same thing with negative 1, okay? Only in the denominator. So negative 1 here. Negative 1 minus 3, negative 4. Okay, not 0. Negative 1 squared is 1. Minus 9, negative 8. Okay, not 0. And negative 1 minus 3 is positive 2, not 0. Okay, so that also is perfectly fine. So then you would write this as your two solutions. Okay? Now, just keep in mind that on the exam, you don't have to check. I don't need to see your check, but you have to make sure that the final answer that you're writing on the exam is correct. For example, if one of the answers was 3, that would have to be eliminated, right? For example, let's say that you got an x equals 3. When you come here, 3 minus 3 is 0. That is not allowed. Then on the exam, you would have to do this. Remove this one because that causes division by 0. So this is how you solve rational equations. All of those 4 steps are necessary, and at the very end, you have to check to see if it passes the domain.